welcome to the tutorial covering section about graphing and solving quadratic inequalities. We're going to cover this. We're going to go back a little bit. We're going to really take it down and we're going to break it down to the basics. In order to be able to do what this section talks about, it's going to be really vital that I be able to graph a quadratic function. If I can't graph it, then there's no way to do what we're going to ask you to do really when we get to the main part of the chapter. So just for a second, we're going to go back. We're going to talk about graphing quadratics. How to graph a quadratic function. Number one, you need to find the vertex. Okay, that vertex we found. Now, I'm assuming that our equation is going to be in a standard form. Okay, so vertex is going to be in x equals negative b over 2a. This is going to give me the x coordinate. I'm going to take that one, plug it back into my equation, just like I have here, and I plug that value in, and what it gives me is my y value. Okay, and you can see that right here. So we found it, x is 1/2. We plugged 0.5 back into my equation, and I came out with my vertex of 0.5, comma, negative 2.25. And you can see on the graph, I've actually labeled that with a red dot for my vertex. The second thing we're going to do is we need to identify at least two other solutions, or two other points on my graph. To find two other solutions, I'm simply going to two ways. I could factor. In this particular example, it's possible that I can factor it. So I went ahead and factored it. To me, that's the easiest, the quickest way to do something. And so I see my zeros, 2, 0, and negative 1, 0. And those points are located here and here. Sometimes it's not factorable, and so we have to try that a different way. And I'm going to use my table of values to set that up. And I'm going to pick points. So my vertex was 0.5, so I'm picking numbers that are just smaller than 0.5 and just bigger than 0.5. So I go down to the next whole numbers. That would be 0 and negative 1. And the numbers above it would be positive 1 and 2. I plug those values into my original equation, and I work those out, and I get some points. And it turns out that two of my values happen to also be the zeros that I used originally. That doesn't always work out. And you can see I plotted 4 points on my graph, and it's clearly, you can see the parabola that would happen. And the only thing left is to simply draw in my parabola, and I'm not going to do that at this point, but you get the idea that you could draw it in just right through these dots, clearly seen. If you can't do that, you need to stop the video, you need to go to your section, and you need to pull up section 3.1 or go back to the 3.1 video. Rewatch how to graph this. I did that in detail on several different videos depending on what kind of information we started with. Was it vertex form? Was it intercept form? Or was it standard form? Check the videos out if you need a bigger refresher than what we just went through. We're going to go on and talk about inequalities now. Now to get to the real information. So basically, let's pull back just a second. What we're going to be looking at here is an equation. This is, what do I need to know? Well, number one, I need to know how to graph a parabola, just like we got through talking about. Number two, I need to know if I'm going to be using a dotted or a dashed curve, or is it going to be a solid curve? The last thing I need to do is I need to determine, am I going to shade above my graph or below the graph? The equation, or the inequality that we're going to be working with, as you can see on the screen, is y is less than negative x squared minus 2x equals, or plus 1. Let's take this a step at a time. If we go down, we're going to basically take this apart just like we would before. I find the vertex, negative b over 2a, okay, plug it in, worked out to be negative 1, work that out, turns out negative 1, 2 is my vertex. I went ahead and I plotted that in a red dot on my coordinate plane. I go back, you take it here, and you've got your values located right there. I find my vertex, negative 1, comma 2. Easy enough. The second thing I'm going to do is find some additional points. Let's try to factor this one. You'll recognize really quickly. I went ahead, here's my equation. I don't like having negative 1, so I went in and divided every term by negative 1. And so it gets rid of the negative signs. But here again, I'm stopped because this is not factorable. So go ahead, don't waste any other time in trying to do it a different way. Go ahead and use your table of values. I went ahead and I put my vertex, -1, 2, in the center, and I got two numbers more negative on the negative side, and I got two numbers on the positive side, and I went ahead and plugged those numbers in. Fortunately, they turned out to be really nice whole numbers. It doesn't always give you whole numbers. As you can see on the graph, I've got the additional points labeled in green, and we can see it that way. The third step is to draw in a parabola and then check to see if it's going to be dotted or dashed, or is it going to be solid. Well, if we go back to our original equation, we look here. It says y is strictly less than. If it's just less than or just greater than, then the only thing you're going to do is use a dashed line. If it's solid, then it's going to have less than or greater than or equal to. So it's going to have that equal to portion written underneath that less than or the greater than sign. If that line is there, then you make your line solid. In this case, it's a dotted line or a dashed line, however you want to think about it. And I'm going to go ahead, and you can clearly see that it would dash, 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 dash all along this curve right here. Alright, here we go. Drawing in my parabola, making sure that the dotted line, and I agree that it is pretty ugly. Dotted line that's supposed to be straight, yeah, that's pretty, but you get the idea. So we've got our curve, or curve drawn in. Now, in order to finish this up, I'm going to have to know, well, do I shade inside it, down inside here? Or am I going to shade outside above the curve? Okay, now my coordinate plane is extremely large here, so I don't expect you to have to fill in all of it. I get the general idea. So let's go back and let's use a test point. I really love to work with 0, 0. If I can use that point to test, that's going to be the easiest, because 0 times 0, 0 plus 0, 0 squared, all those things work out really nice. And so the one thing that I cannot do is use a test point that's on my curve. And I'm looking at my point here. 0, 0 is definitely not on my parabola. In fact, 0, 1 is. So that definitely can't have a point right underneath another point. So I'm going to go ahead, I'm going to use 0, 0 as a test point. Right? So we're going to use 0, 0. We plug it in. 0 is less than negative 0 squared minus 2 times 0 plus 1. This is why I like 0, because all that just goes away, and I've got 0 is less than 1. That's, in fact, a very true statement. So we're going to come back up here, and I am going to take this curve, and I'm going to shade wherever that point was. Well, 0 is inside or underneath the curve. So I'm going to take that, and I'm just going to shade that in, and this is going to be pretty ugly, but you will understand what I mean. This is not a drawing program. You know, and depending on how far down your curve goes, you'd shade all the way underneath your curve. Okay, my curve only drew down to that far, so I'm just going to leave it like that. And so you get the general idea. This curve, or this picture, is my solution. So whenever I ask you to do an inequality or solve an inequality with it's got y as greater than or less than something with x squared, then your picture is going to look something like this. Rewatch that part, double check it, and make sure that you understand how to graph it, how to apply the curved, the solid curve or the dotted curve, and then where to shade by using your test point. One last thing and we'll be done. One last part, which is we're going to talk about finding solutions on a number line. The number line is basically a way that we can, I guess the way that you identify this is if you look at this one, you got x squared minus 11x plus 24 is less than or equal to 0. There's one variable. I don't have a y here. So what I'm going to do is I really need to just find my critical values, my zeros. So I can factor that. I can use the quadratic formula, however you want to do it. but I need either they need to be a whole number or they need to be decimal, because I'm going to end up putting these things on a number line. This one's easy enough. I can factor it. 24 is 8 times 3. That's also 11. And so you see it here. X is equal to 3 and x is equal to 8 by setting each of those parts equal to 0. And you can see the point here, I put a solid dot on each side. And you can see that this is less than or equal to. And so I looked at that, I filled it in. Now the question is, do I shade? Now you can of course see my solutions already shaded in between, but how do I know if I need to shade outside here, or inside the two numbers, or outside the top end? Generally your solution is going to come in one of two ways. It's either going to come shade inside, or you're going to shade in both places outside. You don't ever usually shade in just one place outside. That wouldn't look really, you know something's wrong if you did that right. Alright, I put my values on a number line, the 3 and the 8. I'm going to test the point 0, 5, and 10. One number below, one number in the middle, and one number above. Now, you don't have to test all 3 points. Technically, I could test 1 point and know where it is. If I tried 5 first and I got it to be true, boom, I'm stopping, I'm done. If I tried 0 first and I got it to be false, well, I know it's going to be inside. Now I went ahead and tested all 3 just in case you wanted to see them, but know that you do not have to do all 3. In fact, I could get away with just doing 1. Plug in 0, turns out to be false, so I'm not going to shade there. I plugged in 5, turned out to be true. -6 is less than 0, so I would shade there. Plugged in 10, and I got out 14, so that's not true. And you can see the shading goes right in here. That's all you got. And that is how you would solve an inequality on just a number line. A lot of the times what you'll see is this one will say solve algebraically, or you'll just simply see no y value or no y at all in your equation. All right? Always remember, if you have a question about that and you're not sure what the question's asking, you can always ask me. I have no problem in explaining to you exactly what the question's asking.